When we are solving system of equations, step 1, solve one of equation for one variable. And it will always be easy if you solve for the variable that has a coefficient 1. So either x and y has coefficient 1, then it will be easier for calculation purpose if we solve for that variable first. So in this case, none of the variables has coefficient 1, so it will not make any difference if you just pick one equation and solve for one variable. So I'm gonna take the first equation and then solve that for x. Okay, so solve this for x. That means I have to get rid of y first. So 5y is going to be subtracted from both sides. So then 2x equal 6 minus 5y. Then I can divide each of this number by 2, and this will give me x equal to 6 divided by 2 is 3, and we have 5 over 2y. So I'm just gonna put this here, and then go to step 2. So step 2 will be plugging this into either equation. So step 2, plug x equal 3 minus 5 over 2 in one of the equation. And this can be, as I said, in any equation, in one of the equations. Okay, and let's do that here. So I decided that I'm going to plug it into the second equation. So this is going to be negative 3 times 3 minus 5 over 2y plus 2y equals negative 1. And this is the equation that I now need to solve for y. So solve this for y. And that requires several steps. So first we need a distribution, then we need to collect the like terms and so on. And let's do that on the next page. So negative 3 times 3 minus 5 over 2y, then plus 2y equals negative 1. So we're going to distribute now, multiply this 2 and multiply this 2, and then combine it. So 3 times negative 3 is negative 9, and then negative times negative is positive. 3 times 5 is 15. Y plus 2y equals negative 1. So these two are like terms, and this number shouldn't be here. So we should move it to where the other number is, and I'm just going to do an inverse operation to move it. Then we have 15 over 2y plus, and this is 2 over 1y because it's just 2, and that is going to equal to 8. Now, because these two are fractions, so I can just go ahead and multiply both sides by the denominator of the fraction, which in this case I have two denominators, so 2 and 1, and the least common multiple of this number will be 2, so then I will just multiply both sides by 2 to get rid of the fraction and then combine it again. So 2 times 15 over 2, that's 2 here, y, plus 2 times 2 over 1, y, equal 16. This 2 cancels out. So then we get 15y plus 4y equals 16. Then we have 19y, if I combine these two because they're like terms, 16. Then I can divide both sides by 19. So this 2 cancels out. Then y equals 16 divided by 19. And this can't be simplified because 19 is a prime number and 16 is not, so they do not have any common factors. So we have the value of y. So now I'm going to pick an equation and plug this number in, and then solve for the other variable. So let's pick one of the equation again. Let's take this time the first one and plug the value of y in there. So it's the first equation is 2x plus 5y equals 6. And then our y value is 16 over 19. So we're going to take this and plug it into the y value right here. And let's do that over here. So 2x plus 5 times 16 over 19 equals 6. And 2x plus 5 times 16, that's 80 over 19 equals 6. And 2x equals 6 minus 80 over 19. And there's going to be 1 here. So then we can find at least common multiple of denominator, which is 19. So multiply top and bottom by 19. So now we have 6 times 19, which is going to be 114 divided by 19 minus 80 over 19. And this will just be 34 over 19. And this now requires one more step, which you can just divide this by 2, both sides. Or when you divide it, that will be the same as multiplying by the reciprocal, which is a half, and this 2 be cancelled. So 17 over 19. That's the value of x. Now we say, let's take it here. Now we say that the solution to this equation, solution is going to be this pairs, and this pair is called a point, and this point will be a common point to both equations. So then the solution is the x value is 17 over 19, and the y value is 16 over 19. That's the solution of the equation. And sometimes we'll have equations. Let's look at another example. So we have an equation as x minus 2y equals 5. And then we have another equation that is negative 2x plus 4y equals 3. And if you try to solve this equation using the same steps, which the first step is solving one equation for one variable, and the one that has a coefficient 1, which is the variable x here. So this will be easier to solve. So then x minus 2y equals 5. Then we have x equal to 2y plus 5. Then step 2, I'll take this and plug it into the second equation. And the second equation is negative 2 times 2y plus 5 plus 4y equals 3. Then distribute this. So it's negative 4y, negative 10 plus 4y equals 3. Now I'm going to combine like terms, which in this case, this and this are like terms, and negative 10 shouldn't be here, it should be on the other side where the other number is. So then I'll just go ahead and add 10 to both sides, which now I have negative 4y plus 4y, which needs to be combined, and then I have 13 here. So then I get 0 here when I combine these two numbers, because negative 4 plus 4 is 0, and 0 equals 13, which is odd. So that shouldn't happen. And this statement is, of course, false. 0 cannot equal 13. So this is indicating that this system will have no common points. When you solve the equation and all the variables cancel and you get a number equal to another number, which if that statement is not true, then the system does not have any solution. And geometrically, what this means is line 1 is parallel to line 2. So meaning that these two lines will never intersect, they're parallel to each other. Therefore, they will never have a common point. So finally, we say that this system